Hello, today we're going to start looking at solving our problems with patterns. So patterns is where we just have lists of numbers or lists of pictures, and there's going to be a relationship between the numbers in our list. So let's have a look at some examples here. Now, a formula that's going to be very important where we have something called linear patterns, just like we've had straight lines, graphs of straight lines before, we're going to have linear patterns. And in linear patterns, we're going to use this formula from our log tables. So this is an important formula from our log tables. It's on page 22 in your log tables. So page 22 in your log tables that we'll have for our exams. This is the formula we need for linear patterns, for straight line patterns. Now let's get into an example, and we're going to use this formula in a minute. If I have these dots going along here, and this is the first term. So in the first instance, in the first case, I have 2 dots, and in the next instance, the second instance, I have 1, 2, 3, 4, 5 dots. And in the third instance, the third term in my list, I have 1, 2, 3, 4, 5, 6, 7, 8 dots. So I have 2, and then 5, and then 8 dots. What would be, how many would be in the, how many dots would be in the next term? I think is actually one of the questions. Draw the next term is one of them. But to know how many terms would be in, how many dots would be in the next term, we have to understand the relationship between the terms. So what's happening each time as we go up in our terms? Well, to get from 2 to 3 and 5 to 8, we could do add 3 both times. If I added 3 to 2, I get 5, and add 3 to 5, I get 8. So how many dots would be in my next term? Well, I'd add 3, and I'd end up at 11 dots. So there should be 11 dots in my next term, in my fourth term, because we're going up by the same amount each time. Now, this is what it means to have a linear pattern. We're adding on the same amount each time, or taking away the same amount each time. So first question we have is the pattern linear? It's yes, because the difference between each term is the same. The difference between the terms equals plus 3. So the difference between each of our terms is just plus 3 every time. So that is the definition of a linear pattern, where we change by the same amount each time. This is effectively our slope. So our plus 3 here is the slope of our line for a linear pattern, a line pattern. So we can go to part 2, draw the next term. Well, the next term we figured out should have 11 dots. So I just put in 11 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If it asks us to write the next term, we just draw the next term, looking at the pattern that we can see. How many dots would be in term 5? Well, in term 4, there were 11 dots, and I know that I'm adding 3 each time to get to my next term. Sorry, that should only be an arrow going across once. To get to my next term, I'm not going to have space to draw it, but to get to my next term, I'd just add 3 again. So I'd have 11 plus 3 equals 14. So there'd be 14 dots in my next term, in my 5th term. And I could keep, if I wanted to find higher ones, I could just keep adding them. But now we're going to come to our formula. And this is a formula that's going to give us the number of dots for any term. So if I wanted to know how many dots were in the 100th term, if I had 100 of these pictures all listed out, how many dots would be in the 100th one of them? Well, if I want to know that, I'd either have to do a huge amount of drawing out dots or listing out numbers, or I could use this formula that is going to tell me how many dots there are in each term in my pattern. So let's see if we can use this now. We have a bunch of different letters in them, but they're always going to mean the same thing. We have the number of dots, Tn is the number of dots, is equal to A is the first term, just like A is the first letter in the alphabet. A is the first term, which is 2. There are 2 dots in my first term, so A would be 2. N is the number in our pattern that we are dealing with. So N being 1 would be our first term, N being 2 would be our second term, N being 3 would be our third term. And then D, sensibly enough, stands for the difference, I should say. The difference between each term. And we know that that's the same for a linear pattern. So in this case, it's going to be +3 because the difference between each term in our list is +3. So every time we want to find out about the relationship between the terms and the term number, or the nth term, or they could just ask us for Tn, anytime we're asked about anything like that, we're always going to write down this formula from our log tables, and we're going to find out what A and D and N are, if we can. So A is our first term, is just 2, and D is the difference, it's +3. So I put that into my formula here. I have 2 plus n minus 1 multiplied by 3. Now I have a number outside of my bracket, so I know from my work in algebra that means I multiply it by each number inside. And that means I'm going to end up with 2 plus 3 by n is 3n, and 3 by minus 1 is minus 3. So Tn is equal to 3n plus 2 minus 3 is minus 1. So this is a formula that tells me the number of dots in any term in my pattern. So if I wanted to know T1, this is an aside, if I want to know T1 would be equal to, I put in a 1 for my n, because my n is my number of my term. That would be 3 by 1 minus 1 would be equal to 2. And I know that that's true. The first term is 2. And if I sub in any value of n I like, it will tell me the number of dots in my particular term. So that's how my formula works. Now we're going to get another chance to practice that in just a moment. If I have this pattern here, so this is a new pattern, 1, 3, 5, can I see any relationship between the numbers here? Well, I can see that I have 1 to 3, I added 2. 3 to 5, I added 2. So what would be my next number in my pattern? Well, I just add 2 again, and I would end up at 7. And I'd add 2 again to get to the next number, and I would end up at 9. And that would just keep on going. So my first term is 1, my second term is 3, my third term is 5, my fourth term is 7, and so on. So my little numbers down here are my n numbers. So n is 1, n is 1, then n is 2, then n is 3, then n is 4, and so on. So those are my numbers in here. So if I wanted, in the first part I'm asked here, draw the first 3 terms on a graph. So I put my term numbers, my 1, 3, 5, 7, 9 are my terms in my list. That's going to go on the y-axis. And my numbers for n, the n numbers that tell me whether I have my first term, my second term, my third term, my fourth term, or so on, they go on my x-axis. So I want to put my x and then my y for my points. So my points are going to be, my n is going to be my x values, and my tn is going to be my y values. I remember back when I was creating my points for my graphs. So I have 1, 1 is my first point. 2, 3 is my second point. 3, 5 is my third point. So now I have my points. N is my x value, and Tn, my term numbers, are my y value. So I go to my graph, and I have my first point, start at the origin, in the door 1, up the stairs 1. That's my first point. I think I'll do that in blue. So 1, 1. 2, 3, in the door 2, up the stairs 3. And in the door 3, up the stairs 5. Now this is a linear pattern, so this should all be in a straight line. So I'm going to get my ruler and draw in my straight line. So I have my straight line drawn in with my ruler. Because it's a linear pattern, I use a ruler to draw in my straight line. And I know that the slope of this line is 2. So the slope of this line is 2 because I'm going up by 2 each time. So if I get my slope here, I've gone across by 1 and up by 2. So my slope, put that slope, equals 2 over 1. Rise over run. Now, final part. What is the 20th term? So I don't want to have to write out 20 terms. So if I'm asked for a big number of terms, I can, up to a certain point, just list them out, write out a long list. But if I'm asked for like a 100th term or something like that, I really don't want to have to write out 100 numbers. So what I do instead is I'm going to use my Tn formula. So if they ask me for a big number term, I'm going to find out what Tn is. So I'm going to write down my formula. And A is my first term is 1. And D is the difference between each of my terms, which is plus 2. So I sub that in, and I'm going to find out what the general term is, or the nth term is, and then I can find out what the 20th term is. So 1 plus n minus d is 2. So I multiply my 2 by each thing inside the bracket, just like I always do with multiplying in brackets. 1 plus 2n minus 2 is equal to 2n minus 1. And that is my pattern in general. And I want to know what T20 is, what the 20th term is. So the 20th term I could write as T20. For the 20th term. So where there's an n, I'm going to put 20. And I get 40 minus 1 is equal to 39. So my 20th term in my pattern is 39. And that's how our formula works if we want to find a big number term. If they just ask us for the 10th term, I could just write out the list. But if they ask me something big like this, I find Tn first, and then I put in my value for n. My 20th term would be T20. I put n as 20. And that's what we need for solving our